Good morning, everyone. As most of our attendees are from either New Zealand or Australia, or good afternoon to anyone else that's joining us from around the world. My name is Erin. I'm the Business Development Manager here at Softree. And with me today, I've got Matthew Dickey. He is our Training Manager here and one of our Applications Engineers, as well as Tim Petro from Fergus Rural and associated with the New Zealand Forest Growers Research Association. So we're really excited today to share with you something a little bit different from what Softree is used to talking about. Today we're going to be talking about a new function in our software, a pre-plant forest system design tool. That being said, a quick introduction to Softree. If you're not too familiar with the word, you might know us as the RoadEng people. So we are a proudly Canadian software company. We've been around, oh goodness, I think it's about 36 years now, based up in Vancouver, Canada. Our main product and what we do best and we do really, really well is we do road design. So RoadEng is a tool that I think actually many of you within your organizations actually leverage it. It's a resource in rural road design software. And we also have some cable harvesting tools. So we've kind of specialized in that forest engineering side of things. Well, we're pivoting into a slightly new space, which is digital planting. And I wanted to sort of take a moment to acknowledge how we got here. So we had some conversations, or we were approached by Tim a while back as he was looking for tools to really support planting and thinning operations. And together we worked with Tim to create a very manual plan to assist him with some of his harvest planting. So this was done manually in the software with a little bit of a painful process, which made us think there certainly is some opportunity here to automate that manual, and I'm going to say rather painful process that we went through. I think it took like 12 hours, like a large amount of time. So can we automate that task to not only improve the speed at which we're able to generate sort of that digital planting plan, but to also improve the solution quality? And that's kind of where we are today. We have a new tool inside of RoadEng that you can use to figure out where to plant trees, to support mechanical harvesting limitations, of course, for use on sort of steep and moderate slopes. And we're able to create planting features that really do honor those limitations. And I should say, our development team usually shies away from pretty much any custom development work, but really this digital planting tool kind of checks the box for us on something that we want to look at. It's got some broad utility, very complementary to the functions in the rest of our software. And I think most importantly, I think it's something that has the potential to make some of our users and clients extremely happy. So giving them something that would drive some efficiency. For more context, and from someone who actually knows a fair bit of this new space that we're moving into. So as I mentioned, we're road people. I'd love to turn it over to Tim to give us a little bit of an introduction. But first, I have some disclaimers. Some fun disclaimers. What's a webinar without a couple of disclaimers? So first off, this is a brand new tool. And when I say brand new tool and hot off the press, I literally mean the version that my colleague Matt will be running here today was made about an hour ago. So we are running with a feature and a product that's very much still in development, but really, really excited to share it with you today. This feature is part of a bigger, broader RoadEng release. That's version 12. It's going to come out later this year. But we are going to be releasing this tool into advanced beta testing. And so that's gonna be coming up in the next week or two. And really that's kind of my last point. Collaboration certainly makes this better. We are road specialists. We're stepping into new terrain, pun intended. And really your feedback helps us to build tools that allow it to work better for you. So yeah. You guys are the first to see it. We'd love your input for how to help refine it, whether that's just feedback off the webinar today or perhaps involvement in beta testing. And certainly clients, there's so many of you that have joined this call today. Yeah, welcome. Email us. We'll get you hooked up with the beta. I'm hoping for within a week, maybe 2 weeks. I know planting season in New Zealand, Australia is very fast approaching. So what other disclaimers? Oh yes, the last one, of course. This one's more just a polished one. We typically like to put on webinars that are beautiful, very well polished. But we foolishly booked a webinar on working with large data sets literally just moments before this. So we're really coming out of that one hot into this one. So yes, if we fumble a little bit, please be kind. Okay, Tim, that's it for my disclaimers, my brief intro. I'm gonna pass the mic over to you.
Thank you, Erin, and good morning, NZ, and a very early good morning to our Australian friends, and obviously afternoon and good evening to Canada. So I'm Tim Petro, based in Gisborne, and I do some project work for the Precision Silviculture Program at FGR. And so just on FGR for those that don't know everything about it. So this work is supported by the Precision Silviculture Program led by Forest Growers Research, and the program's funded by the Sustainable Food and Fibres Futures Fund. We are in year 3 of 7. We've got 30 live projects across nursery through to final thinning, and the objectives are mechanisation, automation and digitising work across silviculture in New Zealand. So this work for forest design actually sits in our thinning work stream, but it's obviously got links back to planting and establishment. We're at a bit of an interesting time where some areas are more advanced than others when it comes to mechanisation, such as thinning. However, it's forcing us to think differently about how we design our forests and plant them, even though the plantings are still largely manual and a lot on contour. So we will no doubt see a shift to mechanisation and planting and de-risking like we've done in the harvesting space over the last 10 years really. So for today, but we're going to focus on the design of the forests and how we can set up a digital plan pre-planting. So as Erin said, yep, we went and looked at some mechanised thinning operations in Australia at the end of 2023, and they have some pretty cool things going on with tethering and things like that. And I noted the layout of some of their stands of trees, and they had a kind of a herringbone sort of look to them. So if you can imagine the bones coming off the backbone of a fish, and that backbone being your ridge, and then all these rows of bones coming out to the side following the slope. So it was still manual too, just to add, sorry, very manual, nothing digital or a special program for setting up these layouts. Sort of kind of done on site with the contractor and the supervisors. So on return to NZ, I felt we needed to go back to the desktop and just do some actual pre-plant planning if we're trying to optimize these later operations. And it may not just be thinning, this could also carry through to harvesting, but we needed this to be digital. So as harvesting has lots of roads, access roads, extraction roads, machine pathways, skyline roads, and having been involved with RoadEng before, I decided to contact RoadEng. So I sent a message to the software help desk, and a number of Zoom meetings led us to a trial. Dunedin City Forests had a greenfields area, and they were very keen to be involved because they're starting to look at sort of mechanisation around their thinning operations. So it was really cool to have them involved. It was reasonably easy country, but a very good test site. It's only 70 hectares of extra pasture. So then we basically, in brief, we set it up on RoadEng with 70,000 dots essentially, which represented a tree with its own geolocation. We whacked that on a Venza map, gave that to the contractor, who then set his employees off on the Monday morning following where the direction of the dots, which was essentially the optimal layout for the mechanisation plan. So big change for them from contour planting. A few grizzles here and there, but nothing too bad. And so the roads were coming off the ridges to allow best access for the thinning machines. Essentially, this information could end up in planting machines, could end up in drones for pre-plant spraying, or in cutover it could be useful in land prep machines, so they set the layout with the windrowing. So each tree, as I said, would have its own geolocation and essentially its own identity for future operations. The forest layout then would show its own parameters and exclusion areas. You know, you like your arc sites, your boundaries, your roads, your waterways, and a bit of further thought, given some of the difficulty certain people having in certain areas, could be used as a very useful tool to show our regulatory authorities as part of the consenting and permitting process prior to planting. So that's basically in a quick explanations what's been going on from my end. But I just want to say a massive thanks to Matt and Aaron from Softtree. These guys have been outstanding to deal with. So thank you guys, and look forward to the questions and feedback, because there will be loads of useful extra stuff that you guys can help us out with. So pass it back to you, Aaron. Thank you.
Awesome. Well, thank you, Tim. Thank you for all that fantastic context. And thank you for giving me credit to something which I played such a small piece on, but I accept it. I will take the credit. So yeah, I'll stand in front of an awesome team that put this together. Yeah, our development group, I think, did a pretty phenomenal job. So let's move into showing you guys the fun stuff. So I'm going to highlight high level describe the workflow that we're gonna see today. So pretty much anything inside of our software, it's going to start with the creation of what we like to call a digital terrain model. This digital terrain model can be from LiDAR data, can be from DEM data, can be from drone data. And if you wonder how to work with lots of it, go check out the webinar that we did an hour ago, because we literally just talked only about that. But step one, create a digital terrain model. From there, insert your block data, block boundaries. Yeah, shape file is typical. We can certainly work with lots of different formats. You can also draw and create block boundaries here in our terrain module. As you can see on the screen, the little one in pink was actually drawn by hand. So options for creating some boundaries. We're going to use those boundaries to help us define our planting polygons. So here we'll leverage some terrain analysis tools to discretize polygons based on slope aspect. So we're going to use that, and then into the digital planting tool. So here we'll select the polygons, we'll set our planting parameters, we'll run the tool, and as Tim mentioned, then we can export it. Avenza is a really cool format. We can send it out to Avenza. That is basically creating like a geo-referenced PDF you can access on a mobile device. or on any other device that has GPS attached to it. We can also export out to shapefiles, CSV, or our sort of fancy paperspace tool, which we call Multiplat. And so that's it. Terrain model, create some block boundaries, discretize those into polygons, run the planting tool. Now into the fun stuff. I'm going to pass the screen over to my colleague, Matt. I'm going to remind everyone, especially those of you who might have come late, this version that Matt is using is extremely hot off the press, which means there could be some instabilities, which are getting cleaned up probably as this webinar is happening. But yeah, over to you, Matt.
All right. Well, yeah. Thanks, guys. And yeah, I'll just yeah, total joy working with Tim on this, and a big shout out goes to our dev team for actually putting this together to make it a lot easier to work through the process rather than what started as a very manual process. And with that, I'm going to kind of go through two examples. And the first example we're going to run with is going to be an example based out of Australia. And we're going to use that to kind of frame the problem, talk about what we're doing, and then we'll switch gears and look at the same example that we did the manual operation on previously, and use these new tools and functionality to make that process way easier. So I'm going to pop open terrain here. And I am going to bring in my surface data. So here I just have a DTM file. We can see our surface. And of course, well, we could draw our block boundary in ourselves, but there's a good chance that we already have a projected block boundary that we'd like to consider. So again, we could draw it in if we wanted to, but I happen to have this one as a shapefile. So that's where our block is. And well, of course, we just want to consider in the block, we don't want to consider roads or outside of where we're dealing with. So I'm going to just limit our surface to this to be within these polygons. Oops, and already misclicking. That's yeah, missed a checkbox there. So there we are. We've got our surface, and this tool that we've created. Well, we could go in here. We don't have to automatically create these compartments where we want to control where the trees are going. We could once again just draw in a feature if it makes sense to. So if I want to have something that runs along here, we totally could do that. And I'll make it draped so it's easier to see that on the 3D view. But we could tell the software, okay, I want to take this feature that we have selected, this polygon that we have selected, and I want to create a bunch of points that honor my planting spacing. And I mean, we could go maybe, and yeah, I think in our example, we ran with a spacing between rows of 4 meters and about 2.5 for the tree spacing along those rows. And we could say, well, I want these rows to be oriented north-south, so an azimuth of 0. So we've got that. Now, with this, the big thing that we wanted to consider and focus on is kind of the, well, however we orient this, our main focus is what are we going to do on those moderate and steep slopes. And in which case, we probably want to have those rows oriented with the slope. we can set auto and we can see, well, that's going up and down with the slope here. So that is kind of at its kind of lowest level what we're doing. We're looking at the slope and we're planting or showing where the trees might be along that. Of course, we're putting trees in as points, but as Tim and Aaron introduced as well, we can use this as a guide for where our machine trails might be for actually putting the processor or buncher. Act as the forwarding trails to get that to roadside, and also give us this visual aid where we can start to look at where if we don't have roads yet, where that wood's going to congregate and help us plan landings and roads to get there. So with this particular example, rather than going through and chunking this up based off every kind of undulation in the hill manually, I'm going to come over here and I'm going to tell the software, well, I want to generate a bunch of polygons that are based off aspect. And we are going to turn those into features. So those polygons are going to be exported as features here. And we can see, well, we've got polygons. So there's a polygon. Now here, I want those polygons to control the orientation of my trees within them. So I'm going to select features. I'm going to grab those aspect polygons that we have just created. And we're going to come over here. And just to make it a little easier to see, I'm going to use, and kind of for the rest of this, I'm going to exaggerate our row spacing so it doesn't get cluttered. But we're going to go quite wide just so we can see the difference of our orientation here. Yeah, we're going to hit OK. And it's going to run through. And instead of just having one polygon calculated at a time, we're going to have a bunch of polygons calculated. So we can see what we're up against. Now, kind of, it looks like it makes sense. If we want to get a better feel for what's going on the ground here, we can exaggerate that, kind of stretch it out so the slopes become much more prominent, where we can see, okay, that's kind of a transverse draw and it's going up along the fall line there. And yeah, and just to help this look a little nicer, I'm going to hide those polygons. So this is kind of, yeah, a lot going on. We've got that herringbone kind of pattern that Tim described, where our ridges are meeting. Planter slopes, it's just a bunch of rows going straight up and down the slope. But the reason I started with this particular example is this was one that was used as to implement for actually planting. This was one that's already been thinned and we're using it to benchmark against. And it was blind. We didn't have this information when we ran it. We didn't, I didn't even know we had the information before we looked at it in a brief demo earlier. But the folks at the Forestry Corp of New South Wales were kind enough to let us use this data set. And the really cool thing about this data set is they also have the GPS information from the harvester that was thinning the block. So we can actually see where the harvester had to go, where they were placing those bunches and processed logs. And again, I'll just make a couple adjustments so it's a little easier for folks to see. Sphere, we're going to make that, and we'll make it, sure, we'll go red. So what we see here, of course, there's some differences. One, the the operator was going on a different spacing than what we have. But there's a pretty good match between the orientation we have planned and where the operator was actually running his machine. And they use this example to benchmark against with under the guise that it was one of their better operators that took care of this block. So it's yeah, I think it's quite nice seeing that pattern, how well it matches up with real world data. And then we've got some stuff like this where, well, the operator just came up and then he went straight to the road. And of course, I suspect what we have there is that this is flat or flatter and not necessarily somewhere where the topography is dictating where the machine can go. Because once we get under a certain grade, well, we don't have to worry about a certain slope. We don't have to worry about the side slope and stability of the machine, and they can just more or less drive wherever it makes sense. So that is, I guess, one example. I'm going to just save this, and next we're going to look at our New Zealand data set. So a lot of the workflow is going to be the same, but different example. And this one is kind of easier in the sense that there's more flat terrain, but it's also really irregular with the kind of the incised creeks and the gullies that lead up to them. So same process to start. We're grabbing our topo surface information. And again, another similarity before is we didn't have to start from scratch and draw in where we expected our block to be, although we'll manipulate it if it makes sense. But I'm going to come in here. I'm going to grab the shapefile for the planned block location. And now that happens to be down at 0 elevation. So again, I'm going to just set that on our surface so we can see what we're dealing with here. And well, rather than clipping my surface to that block boundary, I'm going to make my outer features. I'm going to define them as limiting features. And this is a case where I'm going to do this control by changing my feature name, but as we get this closer to beta testing, the UI for a lot of the stuff is going to be a lot more intuitive and streamlined. And then I've got these areas here that I'm going to call no-go. So we could dive right in. We could chunk up our block based off of slope. But then we'd have, well, on stuff like this, we'd have the trees go wherever the fall line is for that relatively flat terrain. And of course, if we're looking at something like that, I expect the operator to just want to go to the road as quickly as possible. So to get around that, we're going to add an extra step compared to last time. We are going to come in here. We're going to, again, create some polygons. This time they're going to be based off slope. And of course, you can put in whatever values you'd like, but I'm going to say that if we have a slope between 0 and 10%, it's not going to be the topography that dictates where we are going. And then I'm going to say, well, if we have anything within this block that is steep, too steep to run a tethered system if we're going to run a tethered system, certainly too steep to track if we're going to track. Well, I'm going to say if we have slopes greater than, oops, and I meant to change this. There we go, slope percent rather than degrees. yeah, so I'm going to go anything steeper than 80. We're not going to go there either. So this is kind of just 2 examples of areas that we'd like to exclude. Of course, it doesn't have to just be areas based off topography. We could add in the buffers for our streams. We could generate our streams in here if we wanted to go that route. Yeah, Tim mentioned arc sites, whatever we want to exclude, we could add that in as polygons that are considered no-goes for this particular tool. We'll hit OK. And here we can see, well, the flat areas are green and the few steep areas that we have are showing up as red. So those areas, again, once this gets to beta testing, we won't worry about changing names. It'll just be select the features that you want to consider. But here I'm going to add those in as no-go features. And then outside of the no-go zones, inside the limit features, I want to create those slope polygons. And aspect. And there we are. I'm just gonna save this before I forget. Again, keep in mind, super fresh. We're still in the midst of alpha testing and refining it. So yeah, just gonna save in case. So these aspect areas that don't include these slope areas, I'm gonna use those to run the tool. And this is gonna be, again, one of those things that we're refining. So it's gonna take longer than it will as we get to the final release here. But I'm going to use the spacing, I'm going to set my spacing along the trees, and on these particular areas, we're going to let the slope determine our azimuth. And we wait. And this piece in particular here is, yeah, it's probably going to be 5 minutes of watching it think. So we probably have,
first thing in the morning in New Zealand and say almost morning in Australia for those of you who are joining us from there. Great opportunity, refill your coffee cup. If you have questions, I didn't really talk about how our GoToWebinar works. There is a question section up in your web browser, or if you're using the desktop version, you can expand the question section. You can type in a question or an idea. We'll take feedback there too, but all question and feedback providers do remain anonymous in the webinar, so don't be afraid to, interact with us a little bit. Yeah, but beyond that, as Matt said, we've got about 5 minutes while the computer does a little bit of heavy lifting. So perhaps, Matt, we did have one question already in the chat here, which says, can you get the tree counts? I don't know if you want to address that one live or wait for folks to get back from their coffee cup refill.
Totally. How about we go both? Yeah, so I'm going to just let this chug away, and I won't open a file that already exists. We'll let it do its thing. But yeah, it's just a matter of selecting your tree features, and then we can see the number of points selected after we do that. So yeah, if you want that kind of bill of materials for what to order, we can very quickly generate that. And likewise, we can export it too if you want it in some other format. So if you just wanted a Excel file with an identifier for each tree and coordinates, we could export that. If you want a digital format like shape or KML, we could export that. But yeah, if you just want a number, we can populate that really for anything at the bottom here. Yeah. And awesome. we're just thinking, it's almost done thinking, so we'll probably hold for the next question until after this, I assume.
Sounds good. Well, I'm glad it seems to be moving faster than our little preview I had earlier today,
Yeah.
which means I don't have to talk about the weather or the fact that it's Friday in New Zealand and I'm really jealous. Sorry, and Australia. Yeah. By the way, happy Friday, everybody from down there. Still Thursday here in Canada.
Yeah. And we've got a solution. So if we poke around here, we can see, well, that's a pretty steep slope. We're obviously going straight up and down it as we hit this little hip here. Oh, we're transitioning. And yeah, there's some transitions throughout, but ultimately it's a complex site that really warrants it. You're either planning for it now or dealing with it later. So yeah, we've got something that is nice and easy to run with. Now this one in particular is nice, and I like this polygon over here. So the forwarder comes up or the processor goes down, what have you. But once they hit this flat, they probably are not going to go any way other than the shortest way to get to the road. So if we want to, we could come in here and we could say, well, from that point to that point, it's a bearing of 49 degrees or an azimuth of 49 degrees. So we can use this tool, and instead of using the auto function, we can say 49 degrees, hit OK, and there we are. We've got that, well, showing the transition once we hit the flat below that threshold that we've allowed, and we are set. So this one, and I won't do the whole thing, as Tim noted, it's not a small block. We chunk up a few more polygons here and orientate them as it makes sense. But if we want to really look at the problem holistically, and through that lens of planting, well, when it comes time to harvest or thin, get this stuff down here, and I'll just pick an arbitrary spot. I'd be surprised if you want to go all the way around to access the road, and I'd be surprised if you're allowed to go through the creek at the bottom. So we're probably in that world where we're back into my comfort zone anyway, and that is the road side of things. So with that, of course, roads are bread and butter, and forest roads are where we got our start. It's where we as a company got our start. It's where me as an individual got my start. Yeah, and of course, from the start to now, things have changed quite a bit. So previously, planning your roads required a fair bit of field work, and then LiDAR data made it, you could do a lot more at the desktop. A little over a year ago, we introduced a new tool called Path Explorer, which really, if we give the software a start point and an end point, it'll figure out where to put the road in between that to minimize your road costs and adhere to your design criteria. So in this particular example, I'm going to run that new tool, and this one is, again, it's pretty benign terrain, so it's not really, well, the whole purpose of our webinar, I guess, isn't really a roads webinar, but this tool will certainly work on the easy stuff, and it'll absolutely shine on the tough stuff. So yeah, here I want to go from that point. I figure I want to have a landing down here. I'm going to, well, put in some design criteria, and we'll let this thing go. So again, fairly simple example, but it's a really difficult problem, and spatially and computer-wise, and we've got a solution. And yeah, one of the options here was we could get multiple solutions, and we'll run with just this one here. So we've got our potential road location. In a moment, I'll take that over, we'll refine it, we'll get an actual design for that. But before we do, before we finish up in terrain, well, assuming that we've added in our different additional polygons where we want to figure out where the trees should be pointed to access those roads. And if we have any other roads that we'd like to add in, we can do that. If we want to get that number of trees, we can select our feature. And we could select it by name, by layer, manually if we wanted to, but we've got those trees down here. So I can see we've got almost 6,000 rows of trees, and we've got 28,000 individual points. And keep in mind, for this particular example, I used a pretty out there spacing. As you're doing it as practitioners, you're going to use a more practical spacing, but whatever you use, the number here is going to reflect what you have in your file. From there, if we want to, we could take that information out. So select by whatever we want to select. So we've got those trees. If we wanted to export them, file, save as, a variety of different formats. I suspect the most common one for folks to want that in will be, where is it? It's hiding on me. Shapefile. So we could hit that and we could say, well, I only want my selected feature and I want them out as points. And then if we wanted to, we could put together our documentation. And here I'm going to, we could leave our polygons in there if we wanted to, if it was helpful to see what's going on for the breaks for planning, but we could also hide them if we want to hide those features. So I've got my features. We'll go and we'll hide. I want to hide my no-goes. I'm just going to select those. And I want to hide all of those. And again, just turning them off so it's a little easier to see what we have on the go. We could change our block boundary if we wanted to, but I'll just leave that as is. If we wanted to, I'll add in an ortho, we could, and I might have one already available here. Oh, I guess I don't, never mind. So I don't have one right on hand. Instead, we can just bring one in from the web. So I'll include that. And of course, if you had your own image, you could bring your image in for context as you run through this process. And of course, if we had anywhere that we wanted to do a little more thorough check on where we want to put things, we can use the image for that added context. We'll throw that in the background. And if we want to put together an actual document to take this out and use it to locate where things are at in the field, well, we can do that. I'm going to just use a screen layout. So it's one of those things you could build it out from scratch if you wanted to, but I don't think we really need to. I've already have a template that I want to use, and there we are. We can see our project. So this document, of course, we can change whatever we'd like for symbology. We could print it out if we wanted to print it, but we could also go save as and export this out as, and where are we at? An Avenza file. You can have that on your iPad as you're figuring out where you want to put things. And then lastly, coming back to that road example here, well, if we want to take that further, actually figure out how much dirt to move and what kind of footprint we wanted to have for that final road when it came time to harvest or support our thinning operations. Maybe we wanted to build it early to just help support the planting effort if it was one of those really long routes and for some reason you couldn't access it in other means. And we'll come in here. So this is the other module. This is location. This is kind of that road design workhorse that yeah, a lot of the folks on the road side of things will use. And I'm going to run with that solution there. So we've got our initial alignment. I won't spend too much time with this, but we've got our cross section. We'll set that as is. And I mean, if you're just really on the preliminary side of things, just what we have here is probably adequate, but it really doesn't take much time to take this right through to the final design level of things. So we've got one curve, the rest of it's a tangent. We can optimize our vertical. And there we are. So we've got a planting plan that's set up to help support our thinning operations and also help support our final harvest operations. And we've thrown together a road in there that we can actually plan around. And here we could consider where that's going to be as we flush out the final kind of little bit of where those rows should go. And yeah, and we could export this kind of similar to a document if we wanted to run with a document. And with that, I'll pause there and
Awesome. Thank you, Matt. So that was a quick introduction to the tool. I see some amazing questions and feedback in the chat, but please, let us know. Give us some feedback. Ask your questions. I know we are officially 2 minutes over, but we're going to hang around and answer as many as we can. But I'd love to direct the first couple of questions actually over to Tim. So Tim, a question for Tim. How practical was it to get the planting contractors to plant trees in exact locations in your first trial? Did it reduce their production costs, their production much, and increase the cost?
Good question. And I've kind of typed a bit of an answer, but good contractor, good forest operations manager we were dealing with, so it made things a lot easier. The contractor understood what we were trying to achieve, and so he carried his Avenza maps and got his guys heading off in the right direction. Obviously not every tree going on the exact location, given that they didn't all have GPS locators. It was about 2 degrees. They'd got the map the day before because we had to push this through. But the end result was pretty good, really. We then overlaid their post-plant spot spraying with the pre-plant digital plan, and pretty good result, really. Obviously some adjustments to planting up and down the slope. I think we set a maximum slope of 20 odd degrees, so once they hit that, they were going back on contour, and that was mainly down towards the waterways anyway. So A, easier for planter, B, somewhere you didn't want to take your machine at a later stage. Costs, don't think there was any adjustments made from the initial plan, but Dunedin City would have to answer that one.
Awesome, thank you, Tim. And yeah, I think this one's a very similar question, but it was, yeah, do you have a plan for how to hand planters these optimal locations? So what really is, yeah, the ideal output to arm someone with?
That's the Liam Walker question.
We don't announce it, but no, it's another one here, which is, yeah, do you have a plan for how to hand planters so they can plant optimal locations?
Yeah, right. So yeah, at this point, as mentioned, open to feedback, but tree foremen and even employees would use vendor maps, very useful tool that you can zoom in pretty closely to show your location, or initially at least we'll be looking at the road direction. The exact location is obviously something still to be ironed out. Work is being done as another FGR project on the GPS space, so it hopefully would then give you the more accurate location. And yeah, as you know, only one trial complete here so far, so we'll keep building on that.
Yeah, very good. Thanks, Tim. Okay, let's go to the elephant in the room, and I'm going to let Matt perhaps share his screen again, which is what is the plan to improve the little odd planting lines, those little random trees? And I think we certainly can talk to where we're going. As we said, we're not even in beta yet. But yeah, Matt, I'll let you maybe share your screen.
It is.
Maybe show the elephant if folks didn't notice it.
So let's do that. All right, and I'm going to go back to here. So yeah, this tool is really in its infancy. Something that we can probably continue to build on and expand on and add to for quite a while. So kind of there's a few rough spots currently, and kind of in the back end of things. There's the ability to minimize, or sorry, not minimize, but limit the minimum size of those panels that I was creating. And right now it's just hard coded, so that's going to be exposed to the user, and then we're going to also have some post-processing magic happen to limit those, as noted, and stray points like that guy up there all by its lonesome. With that, the kind of what's going on there is it's just where the boundary of the two polygons meets, and there wasn't enough room to add anything more in there, but we didn't want to leave a gap. So there are some plans for post-processing to take care of that, and some other kind of things on our hit list as, I guess, as we wade through the process and gauge users' needs and kind of demand how many people kind of want a tool like this, and dictate how far we run with it. But there's a lot of, and those are examples of kind of pretty easy things that we have on our hit list to iron out, and a plan to do it. It's just a matter of doing it. And for us, this is kind of a tool that has come together for us, kind of plugging away. But yeah, we're certainly open to user feedback as we do refine that as well. So as folks test it and play with it, we're interested to hear it. And then the other side of it is in the dev cycle of things. We're showing something off before we usually would. It's still very much in alpha testing and whatnot, so there's lots of rough edges, but that does kind of reflect the fact that we're looking for feedback as we go and making sure we don't make any missteps or overcomplicate it. So Yeah.
Absolutely. And I'm going to just kind of another question or comment here in our chat that's kind of very much along the same lines as talking about those cute little elephants in the room. But yeah, could you set a minimum length of planting line, say, minimum 10 or 20 trees, so that you don't have to have those changes in the planting that aren't really practical to plant out?
Yeah, so not right now, but it's certainly something that we can add, and it sounds like a good idea. So yeah, I guess stay tuned.
Yeah, and I think that's really, we've said it a couple times. We are roading. We are roading people. If you have great feedback and suggestions like that, yeah, let us know. Like it really, in the software development world, we say it's a SMOP. It's simply a matter of programming, and having improvements like that can, obviously make a difference. So yes, please suggest them. We'd love to hear it. Okay, another one for you, Matt, but maybe Tim will want to comment on it as well. If you don't want to outrow thin, can you input every X row? So basically you're wanting, say for example, the fourth row to be wider to accept a machine.
Yeah, so there's two parts of that, I guess. Kind of in its current functionality, the idea was that I'm clicking the wrong buttons, and I need a polygon just so this is acceptable. So yeah, currently, basically you'd have to run through an exercise of using two different spacings, but absolutely in the future we can add that, and kind of as described, it's trivial. And one thing that we kind of cognizant of that and kind of expecting it to be a question, we have the ability to, instead of just having the trees, we can generate a line. So if it's that fourth row that you actually want to show as a line on the map for the guy in the processor to run on, yeah, we can draw that in there and automate it. It's being a line rather than a series of points. But yeah, great feedback again, and I'm sure yeah, Aaron and I get to show off all the hard work of our developers, but they really are the all-stars here, and they're the ones that can add stuff like that in. And I'm sure they'll be able to do that pretty quickly.
Awesome. And then I just want to share, these aren't questions, but they kind of are. I'd love to share it with the group. So one of our attendees said, could you use a drone to drop paint on the locations prior to hand planting? And then the planters just have to go fill in the dots. Yeah, I don't know. Tim, do you want to perhaps comment on that one a little bit?
Yeah, it's a great idea, and again, I think it's something else being looked at as one of the FGR projects actually, because yeah, if the planters are just chasing dots, then it's obviously in the right location, hopefully, and a whole lot easier for the planter when he's not having to consider spacing. If you obviously anomalies come in there when you drop some paint on a stump or something like that. So some on the day decisions required there to maintain that. You'll find some trees out of the geolocation, but certainly again something being looked at.
Awesome. And I realized we had another attendee literally wrote the exact same thing, but they included how much they got a quote for their drone drop painting. So yeah, really, cool idea. Kind of leave that in Tim's space for future comments and investigation. Our next question is asking a little bit about Avenza. So given that Avenza can have 2 to 4 meter GPS error, has this caused issues for the planters? And I'm not sure, Matt or Tim, if either of you feel like, jumping in on that one.
Yeah, so I guess I'll start, and then I'll let Tim correct me, because I'm sure my perspective on it's out of date. But just from another world, not necessarily in the planting space, yeah, if you want to have very accurate positioning with the Venza, you can get an external GPS, and there's a wide array of different external GPSs that you can run with, and they range from being relatively cheap and small and all the way up to quite expensive, but able to give you like centimeter accuracy. But yeah, so that's kind of from another world that I dabble in, not necessarily the planning one. So I'll let Tim give the more tailored answer.
Yeah, well, yeah, I think you've kind of answered it pretty well, Matt. I think a Venza initially, without the add-ons, is really about row direction rather than complete accuracy on true location. But maybe as we move into the pre-plant spots of either of drones or our mechanical planters, they'd both be running much higher level GPS systems in them as far as true location goes. That's about it at this stage.
That just yeah, thinking about that now too. I didn't do it here, and we could add the orientation of those rows as an attribute, and you could label it as well if that was useful, and kind of just not necessarily rely on the GPS, but yeah, I guess discretize what you're looking at and give the orientation, and just use the GPS as a guide, but use a compass if you want to follow the azimuth.
And just on one of those other questions about the short rows, I think you still leave a bit of contractor discretion if when you're doing the manual planting, because obviously some of those short rows just don't necessarily make sense on the ground. So we did see that from the Dunedin examples, that they just carried on rather than creating short rows. So this, yeah, as I say, the planters will use some common sense also.
Awesome. Okay, perhaps we'll do sort of one last question, and then we can wrap up here, which is last question. Can you add set features, such as old stumps, so that the program can use that feature to design planting lines to offset the old planting lines to allow them to achieve their stocking requirements?
I've never thought of that. I suppose we could. Yeah. Yeah, I'd have to think a bit more about it, but yeah, no, it's a good idea. Yeah, and if those features already exist, we could totally just yeah, basically play connect the dots and use that rather than the azimuth as a guide and offset it. So again, another good idea that yeah, certainly worth exploring.
Awesome. Okay, everyone, I think we'll probably wrap up there. So I just want to first off thank Tim. Petro, thank you very much for your involvement, for bringing such a fun, interesting, math-heavy problem over to our team. We love it. We love math and we love doing new things. So thank you for that. And thank you to the audience. Lots of great suggestions, feedback, and that's just from you watching a webinar. But we look forward to, yeah, some of you folks getting your hands on the tool, playing with it. And certainly as you do that, yeah, our team's happy to get involved a little bit, have some conversations if there's something that needs to be added, removed, adjusted. Yeah, it's the fun of making software. Very good. This video, unlike most of our webinars, this will not be going into our public YouTube space. So attendees and registrants of this particular webinar, you are going to get, it's going to be essentially a private video. Feel free to share it internally within your organizations, but as this is a tool that's not even released yet, we're keeping it out of our main channels. So stay tuned for that follow-up in the coming days. And if you have any other questions, please do, yeah, reach out to us. We'd love to hear from you.